my name is Mark Mahoney. In this presentation, I will describe a tool to help instructors guide learners through code examples. The tool captures low-level changes made to a group of files using a popular code editor. Then it allows the programming session to be replayed so that an author can annotate the evolution of the code and explain the reasons behind important decisions. The author-supplied narrative can include text, code highlights, media, and self-grading questions. The combination of the narrative and the evolving code is called a code playback, and playbacks are viewable in a web browser. I will also discuss my experiences using the tool in several programming-focused courses over the last 2 years as a textbook replacement and as an alternative to live coding in the classroom. Several years ago, I noticed that most of my students did not share my love of programming books. They were interested in learning the topics that I was teaching, but they did not buy into the idea that a programming book was the best way to learn. They learned in other ways, of course, but they often bypassed what I thought was a direct way of learning, through a programming book. Traditional programming-focused books and blog posts have two streams of valuable information: the code that does something and the author's explanation of it. There is always a separation of these two streams of information in a book or a blog post. A reader has to stitch them together by flipping pages or scrolling through a web page. Another weakness is that the reader usually can't see all of the code put together in its entirety. They can only see separate fragments. Often I wish I could see all of the pieces in their complete form. Most students love the ease of watching videos. I've created many videos for my students over the years. One advantage that videos have over books and web-based tutorials is that the viewer can focus on the code being written on the screen and listen to the explanation from the author at the same time. Both streams of information are present without the viewer needing to stitch them together. However, videos have some drawbacks too. The code displayed in a video is not easily accessible by the viewer. Videos are not a good copy-paste source and are difficult to search through. A video slider is not an ideal way to find that bit of code that you know is in the video somewhere. More importantly, videos do not encourage the viewer to pause and reflect on what's happening in them. It would be nice if all students had the discipline to hit the pause button and think about the current topic, but all too often they just let the video continue without letting the material sink in. And finally, after having made many videos as an instructor, I also have some issues with the video creation process. I have some anxiety around the performance aspect of making a video that I don't have in a classroom. Ideally, one has to give a solid, interesting performance while conveying useful information. A few years ago, I began thinking about different ways that I could solve some of the problems associated with the media mentioned above. There are parts of all those media that I find appealing, and others that I wish I could leave behind. So I set out to combine the best parts of books, web-based tutorials, and videos into a new medium to guide students through code examples. My goals were to create a way for students to see someone develop code in any programming language, capture how it evolves over time, provide explanations that are linked to the changes in the code, and explain visually what is happening with different media, such as images, screenshots, and videos. I wanted the code and descriptions to be searchable, copy-pastable, and downloadable. Finally, I wanted viewers to be able to see all of this without needing any special tools other than a web browser. I developed a free and open source extension to the popular code editor, Microsoft Visual Studio Code, that I call Storyteller. The extension captures all of the changes to a group of files in an open directory. This includes every character inserted and deleted, and all of the file system changes that occur across any number of files. The tool uses this data to generate and serve web-based code playbacks, which recreate and show the evolution of the code in a web browser. An author can then add a narrative at important points in the evolution of the code. To make a code playback, an author writes code in the editor, runs it, and tests it just like normal. When they've reached an important milestone or have something interesting to say about the code, then they use the web-based interface to replay it and add a narrative. The narrative shows up next to the code as a series of comments. The author can add one or more comments at any point during its evolution. The comments can include text with associated highlighted code, hand-drawn images, screenshots, videos, audio files, and self-grading questions. A viewer can watch a playback in any web browser. They can choose to watch a character-by-character animated recreation of the code, where the playback automatically pauses when a comment is encountered, or to get through the material more quickly, they can choose to see the code only at the comment points. The changes since the last comment are highlighted so that the viewer always knows what has been added or deleted since then. The explanation by the author and the code being described are always present together on the screen. The viewer only moves on when they're ready, and I think this encourages reflection on the material, unlike with videos. I have used this tool in two ways. First, instead of live programming in class, I walk through code playbacks, projecting them on a screen for the class to see. Second, I've created collections of code playbacks to use instead of assigning textbooks. Now, live programming in front of students can be very rewarding. Often, though, there are parts that are just not that interesting to watch. I can usually sense when I'm losing the students because I'm going too slow or I'm just not working on something particularly interesting. Some really interesting things can come up from identifying a mistake and figuring out how to resolve it. I'm all for this happening in front of a class. However, this happens only infrequently, partly because I do practice so much before each class. Most of the time, my live coding mistakes are more embarrassing than thought-provoking. Over the last 2 years, I've been building code playbacks before class, and then I show them to my students instead of writing code live. I move through them by showing the code only at the comment points. In other words, I don't animate all the code changes. The hand-drawn pictures that I would normally draw on the whiteboard are attached to the comments at the appropriate place in the evolution of the code. Now, I don't read the comments aloud verbatim during class. Instead, I describe the code in a way that has a more improvisational quality, although I definitely read the playbacks right before class so that I'm sure not to forget any important descriptions in the comment text. I show screenshots of program output and occasionally make videos of running programs and attach them to the comments. Then I make the playbacks available to the class so students can review them at any point after the demonstration. For the students who review the playbacks later, the written comments are there in place of my live explanation. The primary advantage of presenting code like this is that I can get through the code examples much faster and with fewer mistakes than if I write it live. I notice that I still get good questions from my students about what's happening in the code during the demonstrations. And if I do make some interesting mistakes while preparing the code, then I can keep them and highlight and describe them in the playback. If I make some uninteresting mistakes or I write some uninteresting code, then I can simply choose not to highlight and describe them in the playback. If the students are interested, they can watch the animated character-by-character playback outside of class. Some students struggle to pay attention to a playback demonstration, but these students also tend to struggle with live coding examples. At least with playbacks, they can review the code outside of class at their own pace. The other way that I use playbacks is as a textbook replacement. Instead of finding an adequate textbook, I simply write the programs that I want my students to see over the semester and describe them fully in the comments. I give the students exactly what I want them to see, no more and no less. I try to make the playbacks code-focused and concise. I prefer to show what is happening with hand-drawn pictures and screenshots rather than writing a lot of text. I add self-grading multiple-choice questions to some comments to emphasize important points and to make the playbacks a little more interactive. I collect groups of playbacks and create links to them on the course website. Each playback is a static web page that can be served from any web server. I currently host mine on GitHub. This collection of playbacks becomes the free textbook for the course. There is search capability for searching through the comment text and highlighted code. The code is fully downloadable at any point in the evolution of the code, and the entire solution is always visible during a playback. The preparation time to create these collections is not insignificant. This is the main disadvantage. However, creating collections of these playbacks is less onerous and nerve-wracking than making videos, and far less onerous than attempting to write a traditional textbook. In the last 2 years, I've taught 10 undergraduate computer science courses, a mix of introductory, intermediate, and upper-level courses, with the approach described before. I went through some, but not all, of the playbacks during class and asked students to read others outside of class instead of reading from a textbook. At the end of each course, I gave the students an anonymous survey to gather feedback about the approach that was separate from the university course evaluation. There were 113 students in these courses that responded to the survey. This represents nearly all of the students who completed the courses. I began by asking whether there were enough playbacks. Then I asked about perceived value of using class time to walk through playbacks. Next, I asked how they use playbacks outside of class. Specifically, how many times would they view them? And if they ever use them to help writing their own code. I asked about their preference for a textbook instead of playbacks. Next, I asked about the perceived value of playbacks in the course. Then I asked if they would like playbacks in their other courses. Finally, I asked some open-ended questions. Specifically, did you find the playbacks useful? I'm looking for any and all feedback from learners. What did you like about them? Then I asked, what did you find the most difficult part about using playbacks? What would you change, add, remove from the tool? My analysis of the student feedback is that I created enough playbacks to provide value to the students. Most students approved of using class time to walk through the code examples, and very few were unable to follow along. The students actually used playbacks outside of class by watching them repeatedly and using them to help them write their own code. In some, but not all the classes, I also made videos available to the students to deliver content outside of class. When I had videos covering similar material, 58% of students said that the playbacks were more valuable than the videos. 38% said that the videos and the playbacks were equally valuable, and 4% of the students said that the videos were more valuable than the playbacks. When I did not have videos, 73% of the students said that they didn't think that they would get as much out of videos alone. I was pleasantly surprised by the students' preference of code playbacks to videos. I was similarly surprised by the students' perception of value and preference that their other instructors use playbacks in their computer science courses. I encourage instructors of code-focused courses to try out this new medium of playbacks. That concludes my presentation. I will be physically at the conference and I will welcome questions then. I'm excited about further research into code playbacks, and I'm seeking collaborators to study the use of them more formally. I'm also curious about the metacognitive benefits of students writing playbacks for their own code, and this includes code that might have been AI generated. Please reach out to me through email or in person if you're interested in collaborating. Thank you.